Hello, my name is Brett Carson. I'm doing an IT impact report on data processing and storage, and this is for graduate class BIS 8613, Management Information Systems Administration for Mississippi State University. Basically, today we're going to be doing a brief overview of the paper I wrote on data processing and storage, and we'll just be doing a short outline of data processing and storage, what this means to the CIO, and 3 factors for consideration that any CIO can take into account when considering data processing and storage. And first, we just want to start off by discussing what data is. Basically, data is raw numbers, unprocessed, and what we're trying to do is we're trying to use data processing, which converts data into information, to get that data from just raw, unprocessed to information which is processed and provides some kind of value to the business. And the process and the way of doing that again is through data processing, and that's converting data into information. That's taking data inputs and converting them into some type of information, which is data that is essentially different from the inputs. So different outputs from your inputs. And managers use their knowledge that they have to analyze this data for decision making, and this decision making can be long-term strategic decision making, such as the planning of sales of an item in a certain region of the country over a certain period of time, to see whether they need to increase the storage of that product in a certain location, remove the sale of that item in a certain location, or maybe you can just transfer from a certain type of product to another type of product. And that's just one example. Short-term decision making, this is used by operational and tactical personnel. This can be anything from processing daily orders for shipment to taking weekly inventory accounts or monthly inventory. But this is your short term. Again, these are usually daily, weekly, monthly, and strategic. Long term, these tend to be in years. And the thing that we've got to look at is data processing systems tend to generate large volume of data. And a lot of this data can be regulatory, from your regulating government office that regulates your industry, to long-term planning that we talked about, data going back for many years, to archival data, which could be simple as archiving email. And the cost of data annually worldwide comes to around $1.1 trillion, and the total amount of data in the world today is roughly 2.2 zettabytes. And to kind of break this down, we're going to give you an example of small to medium-sized businesses and large corporations. SMBs make up about 563 terabytes of data. They have an annual growth rate of 178%. Large corporations contain about 100,000 terabytes of the data, and their annual growth rate is around 67%. And here's an example of a 50-employee SMB. This is going to cost roughly $183,500 on management of data. This comes out to around $3,670 per employee, and an overall value of $332,000. An example of a 2,500 employee enterprise, they're going to spend roughly $2.8 million per year on management. This comes out to around $3,297 per employee, and an overall cost of $38 million per year. We're going to discuss now a little bit about data processing. Again, we defined data processing earlier. We're going to give you some examples of data processing systems here. First, we have to define relational database, because essentially all data processing systems in use today, enterprise data processing systems, rely on a relational database, which is based on tables, primary keys, and foreign keys. It uses SQL, or structured query language, as a programming language, and you have to look at relational database management system, which is used to create, modify, and manipulate a relational database. An example of these are Oracle, Microsoft SQL Server, MySQL, and Microsoft Access. Another data processing system example is an ERP, or Enterprise Resource Planning Software System. They integrate key organizational processes into one system, and this is basically taking what at one time would have probably been multiple individual systems from different vendors for different departments and combining them into one large enterprise system. And typically these are order entry, payroll, accounts payable, HR, procurement, manufacturing, and there are several others that you can roll into this, but it's software that's designed to manage your entire corporation. Vendors that provide these services are SAP, Oracle, and you have Microsoft Dynamics. These are just a few. There are many others out there, but these are just a few of the larger ones in play today. Another data processing example is a CRM, or customer relationship management software system, and it's complete management of the customer life cycle. It's basically from the time you gain a new customer through the complete cycle of taking care of that customer. And these typically entail sales, marketing, customer service. And another type of data processing system is business intelligence, and this is a system that analyzes information to improve and optimize decision and performance. These typically are applications, infrastructure, and tools and best practices, and they are best used towards long-term strategic planning. You actually have options nowadays for in-house versus cloud solutions. And in-house is basically the systems being hosted at your location, whereas cloud systems, these data processing applications are typically services offered by somebody through the use on the internet. And some advantages you can have here of using a cloud solution versus an in-house is it actually reduces your infrastructure footprint. There's less hardware that you have to keep on site for these. They can be a low-cost entry point for SMBs who may eventually grow to an on-premise system as they continue to grow. And it lowers operating costs, and you can actually convert capital costs to operational costs. We'll be discussing a little more about in-house versus cloud systems when we do a cost analysis later on as one of our 3 factors that CIOs should consider when making decisions about data processing and storage. Data storage, there are 2 main types of data storage: file and database. File is an electronic list of data that have been optimized to perform a particular transaction. Database is a collection or grouping of information that are related to each other in some way. File formats, these typically are master files, lookup files, transaction files, audit files, history or archival files. These can be Excel files, Word files, PDF, zip, email archives, or just plain text files. Database files, these can be legacy databases, which would be typically older database formats that were used before relational databases. You see relational databases, we discussed that earlier just because of the importance of the underlying format for the current data processing systems. Object databases, these are relatively new. They are growing somewhat. There's not as many applications today that use these types of databases, so it's based on object-oriented programming. And then we have multi-dimensional databases, which typically, when you look at a multi-dimensional database, those are related to data analytics and business intelligence, where you pull information from multiple database formats. And you can be pulling from legacy, different relational database vendors or object databases, and use this for long-term decision making. Data formats, this is just a list of the major strengths, weaknesses, supported data types, types of applications they support, and the future needs of the different data formats. We actually have this listed in a report, so we're just going to kind of briefly go through. The major strength of the file system is that it does have a lot of performance with it. Major weakness is redundant. Supports a simple data format, data type, used for transaction processing. Data formats are organizational dependent. They have very limited future prospects. Legacy database management systems. Their major strength is they are a mature product. The major weaknesses, they cannot store data efficiently. They have limited future use. They're not recommended for new systems. Data formats is organizational dependent. They have very poor future prospects. Relational database management system. This is the main type of database system in the market today. They can handle diverse data needs. They cannot handle complex data. They're used for simple data types, mostly transaction processing and some decision making. Data formats is organization dependent. Future needs are very good prospect for your future as applications continue to grow and evolve. Most of these will still rely on relational database management systems. Object-oriented database management systems, they handle complex data. It's still a maturing technology. Skills are hard to find. Complex data types that are supported: video, audio, images, transaction processing applications. The data format is organization dependent, and it's kind of unsure future at this point because it still is maturing. Multidimensional, these are configured to answer decision support questions quickly. Again, these will be like long-term strategic planning decisions. The major weaknesses, they are highly specialized and require skills that can be hard to find, although these are developing more and more. This is a section of database storage format that is growing. The data type supported is aggregated. The type of application is decision making. Data format is organization dependent. Future needs, uncertain future prospects. I think they have some good future prospects myself, because I see more and more people developing the system as prices come down and skill sets are available. Data storage, there are three main types of data storage: direct attached storage, network attached storage, and storage area network. Direct attached storage is internal. It is block level transfer. You find these mostly in small to medium sized businesses. It is found in standalone servers and PCs. This would be typical like your desktop PCs or servers. This is the hard drive that you install into a PC or laptop or anything that has internal storage. Basically, just about any type of computer system that you find on the market today uses direct attached storage as its main form of storage. The size of this storage can be small to large, and it is pretty easy to admin. Most of the time, it's just inserting the disk and formatting that disk. NAS, these are typically dedicated appliances that you set on your production IT network. They use file level transfer. This is mostly geared toward small to medium sized businesses. An example of this would be a Drobo. This is a NAS application that we use. Their location for shared storage such as spreadsheets, PDFs, application installation files, Word documents, anything that we would share between our employees. Microsoft Access database files, and you can also use this in small virtualization instances. I would stay away from enterprise version virtualization just because these NAS do sit on your production network and it can take a lot of traffic. Typically large in size. Again, these are for shared storage files. You may have installation files that are over 2 gigs, so they can be quite large in size, and they're easy to moderate to admin. As I referenced the Drobo earlier, on this system, basically all you have to do is you put your disk in the system, turn it on, it configures itself to start with, and you install a very simple admin application on either a Mac or PC, and you can manage it from there. Very easy to manage. SANS, this is a dedicated appliance. It uses block level transfer. Uh, Most of the systems that connect to a SANS, they actually see the SANS volume as direct attached storage. That's the way it's designed. It's designed for performance more than large capacity storage. You see this typically in clustering database systems, high availability systems such as virtualization, and large enterprise virtualization systems. These are typically found in medium to large size businesses. They can be very complex to configure and admin, and in many instances it requires a SANS administrator. A lot of time in your medium-sized businesses, specifically if you're using a SANS just for virtualization, your virtualization administrator is probably going to be your SANS administrator. We have 3 CIO factors for consideration here: security, disaster recovery, and cost. We're going to run through these. I basically try to focus on the non-functional requirements of data processing and data storage, as opposed to focusing on the actual functional requirements, because I think the functional requirements are going to be determined by the business needs, whereas these 3 non-functional requirements that can be spread across any data processing and storage system available on the market today. Start out by security. These can be broken down into 3 main threat categories: external attacks, intrusions, viruses, and worms. External attacks, these are attacks against IT infrastructure that can cost millions of dollars in damage. They can result in downtime. The main example of this is a DOS or denial of service attack. These are typically against external facing websites and e-commerce websites. Intrusions, this is where intruders gain physical access to your systems through usernames and passwords, social engineering, packet sniffing, and port scanning, just to name a few of the ways. And again, we do go into more detail into a lot of this in the paper, but for time constraints, we're just kind of outlining this here. Viruses and worms, they can range from defacing websites to destroying the data on hard drives. So there's kind of a wide range there. Defensive measures you can take to prevent these 3 security threats: security policies, firewalls, authentication, encryption, patching, and change management, and intrusion detection and network monitoring. Security policies, these are questions that that can be addressed by security policies. What kind of passwords are users allowed to create for use on company systems, and how often should these change? Who is allowed to have accounts on the company systems? What security features must be activated on the computer before it connects to a company network? What services are allowed to operate inside a company's network? What are users allowed to download? How is the security policy enforced? And these, when you implement security policies, these are the questions that you have to ask yourself before actually implementing policies. Basically, your policies are going to be dictated by how you answer these questions. Firewalls, they prevent unauthorized access to internal resources. These can be hardware and software. They basically filter packets at the front of your network, and as these packets come through, if they do not match a certain set of firewall policies, they're discarded. You can also use Sentry computers, where packets are actually sent to an intermediary computer that sits between your firewall and your other network, and they're filtered through that computer instead of actually being sent to computers on your network. Authentication, this is control who accesses the system. This can be host-based, specifically for a computer. They can be network-based for your entire organization, or they can, in most instances, this is a combination of both. Typically, we use Active Directory. I know we use Active Directory at my current location to do authentication for access to computer servers, network resources such as shared folders and shared files. Authentication, you need strong authentication, and this can be from an example of this would be uppercase and lowercase letters that are required to be of a certain length, and letters and passwords that expire maybe every 30 days. Encryption, this is where information is rendered unreadable and is decrypted by a key. This is set up typically, the key, this works between the devices that are communicating with each other by, when they first establish a connection, they transfer a key between each other. That way that when data is sent, it's basically unreadable. If you were using a packet sniffing device and its data goes through that packet sniffer, you're not going to be able to detect what it is. Only the end device that has the key can decrypt that information. Patching and change management. This is keeping software up to date. You keep your security patches installed, updated, and keep records of all your updates. When you do these updates, that way you know what version of software and security patches you have on your network. That way, if something comes up about an issue with a certain version of software, you don't have to go searching through your whole network to figure out who's updated and who's not. You automatically you know by the records that you keep. Intrusion detection and network monitoring. This is filtering external attacks at network boundary. This is hardware probes and software diagnostics. They log and report suspicious activity. This is very similar to a firewall, except these typically analyze network traffic patterns and they block or report suspicious activity. Other actions that you can do: keep all your doors locked. Keep doors to your organization locked. Keep doors to your server room locked. Keep your server cabinet doors locked. Keep the faceplates on your servers locked. And use like a combination of access methods such as a keypad and access card, or keep access cards and key locks. Also, you keep your antivirus malware programs up to date and installed on all servers and computers within your organization. You can use self-encrypting hard drives. This is basically where the encryption is built into the hard drive. The program that your data processing program that may be communicating with your hard drives, the hard drive exchanges a key with that system, and when that information is written to the drive, it is basically encrypted on the drive, and only the system that contains the hard drive can read the data on that hard drive. So essentially, if somebody breaks in through all your locks and they actually pull the drive from the server, that drive is useless to them. They cannot read any of the information on it because it is encrypted. Only the system that the drive was in knows that information. And also use security cameras in your organization to keep track if something does happen. That way you can actually go back and view who accessed these systems. Disaster recovery. Three main types of disaster recovery: hardware failure, natural disasters, and human error. This can cost worldwide around $18 billion a year. It's been experienced by pretty much all businesses. It says 70% of businesses, but I know personally I've experienced where I work, and these typically, the effects of this typically is loss of profit, or even worse, putting the organization out of business. And here we have three types of disaster recovery solutions. Take external disk backup. This is a high risk, low cost. These are low cost options, but they carry a high rate of risk. If you do not have these stored off site, and say you had a tornado or something come through, blow your organization building away, your disaster recovery solution has gone with it. Hosted solution, these are medium risk and medium cost. This would be such as renting server space from a web company such as Rackspace, 1-in-1, or GoDaddy. This would be like infrastructure as a service type of solution, where basically you run backups locally and then restore them to the cloud. And the reason I say it's medium cost and medium risk, the cost is less than an complete offsite solution, but more than a tape solution. Um, but the risk is medium as well. Your backups are only your hosted solution backup is only as good as the last time you restored a backup to that um, cloud-based solution. And offsite, this would be where you can. This is a low risk, high cost solution. This is basically uh, you have a completely replicated type system infrastructure offsite. This would be uh, completely backing up your entire IT infrastructure offsite. It has a high cost, but it has a low risk compared to your other uh, solutions here listed here. An example of this, I'll give a little bit of an example of the solution that we use at my current location. This consists of Dell servers, VMware virtualization, and Acronis. Last year we decided to go with the virtualized solution. As we did that, it gave us some options for disaster recovery. Our servers, our physical servers, are in a high availability cluster where if one fails, the other one picks it up directly. We have stacked networking where we have multiple switches physically connected together, but they're seen as one logical switch. And our servers and storage devices are redundantly spread across these switches, so that if one switch goes out, it doesn't affect the network transfer from the other servers and storage controllers. We have redundant disk controllers and RAID solutions on our storage devices. That way, if one disk controller goes down, our servers still have access to the information on the storage, the operating system. And then we have the DR software from Acronis. Basically, what this allows us to do, it actually allows us to create a backup locally at our current location, and we actually have a fiber loop, a 96 strand fiber loop connected between our office and one of our other locations, where we have put another Dell server that we've actually loaded up with storage, and they have an option for replication where it will actually replicate an image of each operating system to that location in a standby mode. And then if that other site loses connection to our current office within a certain time frame, which you can set, then it will automatically kick those virtual machines on. So it's a pretty nice disaster recovery solution for us. It is a little bit on the expensive side, but you have to look at how critical your assets that are in your disaster recovery plan are. I mean, if they are, mission critical to your organization, then you're going to spend a lot of money keeping these systems backed up and keeping a very good DR plan in place. Cost analysis. This is based on. This is our third factor for consideration that our CIOs need to take in consideration. To do our cost analysis, we're basically going to look at the cost of 3 different types of systems: on-premise standalone, on-premise virtual, and cloud. And we've used basically 4 different vendors. And we actually put in a set of standards for this of 100 users, a 36-month period, a subscription period / financing period for your on-premise systems and your cloud systems. And we chose a base CRM system for this example because we wanted to use an ERP system, but cloud-wise, not all vendors are supporting ERP at the moment. They're in the process. I think maybe a year from now we could have done an ERP cost analysis, but just since CRM typically was one of the first cloud solutions, and just about everybody that offers a cloud-based data processing solution, we went ahead and decided to go with the CRM. I know there was other case analysis earlier, or other IT reports, impact reports earlier here that discuss CRM in much more detail. So we're not going to go into the detail of the CRM program. We're just actually using it as an example of a data processing system for our cost analysis. We based it on Oracle database software because this is, it's the enterprise relational database management software system that most applications use. It's kind of the industry standard in some ways. So all our pricing is, again, is based on 36-month period. It's based off Oracle database software, and the four vendors that we chose to pursue is Salesforce, Microsoft, Oracle, and SAP. And again, we'll be comparing cloud, the standalone, and the virtual. You can find more detailed information about this in our IT impact report. We do give we do break down the information very specific in the report itself. We're just going to kind of give an overview of our cost here. The first thing we're going to look at is our cloud solution. As you can see here, again, this is based on 100 users for 36 months. We actually priced in a bonded T1 at $850 per month. And when you look at the price range here,
Kevin, call 201. Kevin, 201.
When you look at the price range here, it ranges from, on the low end, $189,000 to, on the high end, SAP at $351,000. And again, this is our high end value here with SAP. They are basically the Ferrari of enterprise applications. And as you'll see, that's kind of represented across all three of these. Salesforce kind of come in the middle there. They're not the highest, they're not the lowest. But Oracle tends to be the second highest across all three of these as well. Our on-premise solution here, the first thing we need to talk about is our SAP price is estimated. I've included a reference to that in the paper itself. Basically, we tried getting a hold of SAP several times, but their pricing is so custom tailored to your organization. They take in several factors that you have to consider for the pricing of their product. That information is not as readily available on the web. So we tried it. We never did receive a reply back from SAP either by phone or email. So for whatever reason, they've not gotten back to us. But we did estimate the price of SAP based on Nucleus Research Group. What they found was that over a 3-year period, Oracle was 48% lower cost than SAP. So based on this reference, which again, based on this information that we did reference in our paper, that's how we estimated our price for SAP as far as their on-premise solutions. And again, here you have $35,000 that you have to consider for Oracle that is included in the total cost. You also, for our on-premise standalone, you have $12,486 per server that you have to include as well. And the fact is, we included one server for the database and one server for the application. So going looking at the total price up here, you have $189,761 for the Microsoft Dynamics CRM product, and you have the estimated cost of $858,049 for the SAP on-premise product. Salesforce, we did not include Salesforce because they do not have an on-premise product, so we just strictly included them in the cloud version. And again, Microsoft is the lowest, SAP the highest, and Oracle coming right after SAP in this instance. Okay, as we move on, we're going to look at our on-premise virtual. And the one thing I want you to notice down here is the cost difference between uh, our virtual machine, which would be cost per server is $4,637. This is the cost associated with, if you look at the previous slide, the standalone, the 12,486. Uh, so you've got 12,486,000 per server as the standalone. And you got 4,637 in the virtual. So you're actually saving almost roughly $8,000 per server by going with the virtual solution. Again, this is based on virtualization, and we've kind of broken this down in more detail in the impact report itself, but this is based on 40 virtual machines spread out across the total cost of hardware here, as you can see. And again, we've included the $35,000 for Oracle, and the total prices tend to come out to $174,064 for Microsoft, $842,352 per SAP, and again, Oracle is right in the middle of all that. But the main thing here is your virtualization. You can typically save quite a bit of money if you were implementing more than one application. Maybe you had some redundancy or different things like that, where you needed multiple servers, multiple databases, multiple application servers. You're going to save almost $8,000 per server by going virtual. On a per month cost based breakdown, we basically have all four products listed here. We have the per month cost for standalone, on-premise standalone, on-premise virtual, and cloud. And as you can see, for most of these, the cloud solution is cheaper. It is quite a bit cheaper for SAP. You've got $9,750 per month compared to over $23,000 per month for a virtual or standalone. But if you do notice some pricing here by Microsoft, their on-premise virtual solution is quite a bit lower. Well, not quite. It's a couple $100 a month lower than the cloud solution. So there's a little bit of savings by going on-premise virtual with Microsoft, and these are a lot of factors that you can take into account. But this is just a cost analysis of 4 different products versus 3 different methods of implementing them. The Salesforce, there was no standalone and no virtual option for that at the moment. And again, the SAP standalone and virtual price has been estimated due to the difficult nature of obtaining a quote from them on that. But in most instances, except for Microsoft, the cloud solution is the cheapest. In conclusion, we discussed data processing and data storage and why these systems are important to the CIO. Also here, we've got listed 3 factors, how they rank. Kind of got a tie in first place here for security and disaster recovery. At one time, security, I believe, would have trumped anything else, but nowadays security and disaster recovery go hand in hand. They both trump cost. I mean, if you've got $900,000 to implement a solution and you implement one that's $875,000, that does not leave much money for a disaster recovery solution. Which, if your organization is wiped out, that $875,000 solution has just become worthless. So just include security and disaster recovery as your main focal points for consideration on any type of new project you take on, and just make sure you have added room in your cost structure for security and disaster recovery, because these are very important to maintain throughout the life cycle of your data processing and data storage. Again, this is Brett Carson. This is the end of my IT impact report on data processing and storage for BIS 8613 MIS administration for Mississippi State University.